Hi guys. Alright, so today we are going to be building a Wordle app using Flutter, so we'll be coding along together. So I'll be building it from scratch. Okay, alright, so for starters, just to like get us up to speed with what I've done so far. So I have this asset declared here. So this asset contains 5 letter, most of 5 letter was in the English language, and then I declared it in my assets like this, so I'm getting it when I run my buckets. Alright, so we only have one Dart file here, which is our main, so I will portion it as I deem necessary along the line. Alright, so let's get right into it. So let's take this off. Okay, so I don't think I'll be needing this home page, so I can yank this off, and then here I can create another file called home. Alright, so right here inside our home, let's make it stateless home screen. Alright, so let's import material.dat. Alright, so that's all this for us, so we can call home here. Let's call home here. Alright, so I have initialized Git so we can see the file changes as we are coding along. Alright, so let's get back to our home screen. So for context, this is what we'll be working with, so let me bring this here. Alright, so let's place this under our scaffold and make this the body. Alright, then let's place this under safe area. Alright, so it's asking us to make everything a const. Alright, so looking at this, we need to separate the app into 2 sections. So we need the keyboard section, and also we need the game session itself. Alright, so let's do that. Let's create a column. Okay, so let's set our keyboard to format or save. So for me, I'm using IntelliJ, so all I need to do is search for action on save and then click on reformat, optimize, rearrange code and apply. Now when I save it, formats the file for me. Alright, on VS Code it might be different, so just try to research on how it works for VS Code. Alright, so let's get the color from here. So I have an extension that helps me get color from page. It's called Colorzilla. So for the background color, it has been copied, so let's create another file called colors. So here we call it class and name it colors, and final static color bg for background xff. Right, alright, so it's as if we made a mistake, so the static should come before the final. Alright, I think this should even be const, so let's make this a constant. Alright, so this works. So this is our background color, so let's get the field color. So we duplicate this and then we paste it here, and then we name it field color. So let's do this once more to get our wrong position color, and then let's do this again. to get our correct color. So this is our correct color. All right, so let's get our untapped color. So this is our untapped color. All right, so let's do this, paste it here and name it untapped color. All right, so let's come to our home screen. Background color, let's say our colors. All right, let's see what we can name this. Okay, it's our color. So let's try importing it again, and then background color. All right, so this works. Okay. All right, so let's convert this now to stateful widgets, and then let's build out the containers. Let's build out this upper part first. So to do this, we would divide the app into two first. All right, now at the upper part we'll use a grid view dot builder. All right, and then we want to shrink wrap set to true. Fix this, never scrollable physics, because we don't want it to scroll. And then our item builder then we want to return some container which we would actually decorate. So we'll be using sliver with fixed cross axis count. Yes, so this is it. So how many axes can do? 1 2 3 4 5. All right, so we want 5. Okay, so how many boxes in total would we have? Would have 30 boxes. Okay, all right, so let's fix this. Okay, so now let's decorate these boxes. So we'll say child text. Let's add T for now, then let's style it. Style, we'll say text style color colors. So we need white color here. So what we need to do is come here, add this dot white. So this is being gotten from material colors. So we'll name this white color. White color. Okay, so this is it on the screen. All right, and then the font size, let's do the font width. Font width is 700. Let's see how that pans out. All right, font size, let's do font size as 14. Okay, so this is fair. Okay, so let's add a little bit of padding. Edge insets, the symmetric. Oh, that's right, I need to add padding here so it should avoid the edges. So symmetrical, on the horizontal we want it to be farther by 20. All right, so this is it. Okay, so let's decorate the container. Let's do box decoration, border, do border dot all color, our colors, a white color. Okay, but I feel like the white is too out there, so probably we might want to change to add a little bit of opacity. We'll make it 0.5. all right, so this makes more sense. All right, so let's make this flex let's make the size box, because it seems the second part of the screen is being cut off. So let's make the size box for now. After we are done designing, we can readjust it much later. Okay, all right, so let's create a margin. Edging says dot all, so let's see 6 for instance. All right, so here's what 6 gives us, an edging size of 6. Okay, all right, I think there's something we can work with. 6 is fine. So let's centralize the text, add this to the center. All right, so this works. All right, so our text container is almost ready. So this is just the text container without the text logic itself. So let's add a little bit of spacing at the top so it looks finer. All right, so let's say 20. All right, so let's build out our text field, our keyboard rather. All right, so to build out our keyboard, we need to have like arrays of strings. So let me quickly do that and then I'll continue the video. All right, so I was able to generate the QWERTY keys. This is the first row, the second row, the third row, and then for quicker work, I think you can use ChatGPT to make it faster for you. I also use ChatGPT to generate this. Okay, so let's build that. All right, so we'll use a row. Yeah, so we'll use a row and then generate a list using a row and list builder to generate each of these keys and then centralize it. All right, so let's see how that would work. So we can add this to a container just so that when we want to extract it, it will be easier for us. Yeah, so here we would have a column, then this column would have children, and then inside this children would have row. Or instead of that, let's use list view.builder. List builder will take escape the index and then escape the context and then specify the index. Okay, then item counts and then physics should be never scrollable physics, then shrink wrap should be true. Okay, then we should return container, and then the item count should be keyboard keys at index 0 row dot length. All right, so I think it's also possible for us to have a list view builder inside a list view builder, but let's be done with this and then optimize it with a list view builder. Instead of having to specify the row manually, we could just use a list view builder and then it will generate it for us. So we know that for whatever key that is being pressed, we hit the callback and the callback gets it for us. All right, so let's do child. The child should be text, and then this text should be final text is equals to at index of high. So this should be text, and then let's come here, copy this, paste it here, and then let's change the direction. So we'll do scroll direction, we'll do axis dot horizontal. All right, so it's throwing an error. Let's try an overflow error. All right, so I think we have to specify a height, let's say 100. All right, let's say 200 even. Okay, so if we look at this, we can see the amount of space horizontally that was occupied, but we'll resolve that in no time. Okay, all right, so we need to do our decoration, box decoration, and then we need to do color app colors dot field color for each of these items, and then add a little bit of border radius. Border radius is circular, so let's say border radius of 5, and then let's do border dot all color, do app colors dot white, and then with opacity of 0.5. all right, so now let's do our margin sense dot horizontal symmetrical, and then on the horizontal we want 5. okay, and then let's add padding edging sense dot all, let's add padding of 5. okay, so I don't think that will cut it for us. Let's reduce our, okay, let's take it to 5. Let's take it to 5. yeah, all right, so let's see if we do these as okay. All right, so let's make this 40. okay, all right, so if we have to like redo this, it wouldn't make sense, so let's actually have it inside a list view. So we'll do here container, we'll do list view dot builder, let's keep the context and then specify the index, and then we want to return list view, and then right here item count has to be keyboard keys dot length physics, so we don't want it to ever scroll, not scrollable physics, and then shrink wrap 2, and then we want final row keys is equals to I. So right here what we need to do is row keys, which is this. okay, so it threw an error. all right, so we can take this out, and so let's make this an expanded widget. all right, so the lower part is throwing an error, so let's try to see how we can resolve that. Let's see if we put it inside a row, then have it expand. That didn't work. all right, so let's see, expanded, and then this guy right here. all right, so this might be a little bit of an issue, so you know what, I think we should change our strategy. So let's render this with a row. So what we'll do is we take this out, then use a row, and then have our children, and then it becomes list of widgets. List of widgets from row keys dot map each item to E. Alright, so this is what we have currently. So what we did was we mapped each of the row keys to list of widgets and made it the children of the row. Alright, so this is what we have. Alright, so to adjust this UI, so there's a flex property. So let's make this 2:1, a flex of 2:1. Let's see what happens. Okay, so this works for us. Alright, so let's see how we can improve this. Alright, so the margin, let's see if we make it all 10. Okay, 10 seems to be too large. 6 as well seems to be too large. Let's do a main axis alignment, the center. Alright, so everything is centered. Alright, so let's see what happens if we use an expanded here. Alright, so this gets overlapped and broken down, so we don't want this to happen even. Alright, so I guess what we'll do is we'll use icons to represent the enter key and the delete key. So if E is equals to enter, then use an icon. Let's see if we can get any icon that represents enter. Alright, so this is like a makeshift solution, and then let's do the same thing for deletes. If E is equals to del, so we want to use icons as well. So let's check for backspace. Alright, so we have the backspace icon. Alright, so let's see if we can use 30. No, that won't work. So let's change the color to white. Alright, so let's do the same thing for this. Alright, height. So to make it the same across board, let's see if we can specify the height and the width for each item. So 50 seems to be too large. Let's make it 30 each. 30 doesn't seem to be cutting it. Let's wrap this inside the center, which just so it stays in the center. So height, we can make height 40. Okay. Okay. So there still seems to be an overflow. So let's see if there's a way we can get that resolved. Let's see if we reduce the width. Okay, so reducing the width might solve it. Let's say 25, 22. Okay, so 22 solves it for us, but it's not looking good. Okay, so let's see if we use fitted box, how that works out. So that doesn't help our cause. Alright, so just one item. Let's see what happens when we... Alright, so I guess I need to take out this padding. Alright, padding taken out. How about reducing the margin. Okay, so let's add a little bit more to the margin. All right, okay, let's increase the vertical margin. Let's say 4 or even 5, and then horizontal, let's make it 2.2. Let's say 3. Also 3 is problematic, let's say 2. Okay, and then maybe reduce the font size. Let's increase it slightly, and then increase. Okay, so this is reduced, so let's increase the horizontal padding. Oh, that's still a problem. 3 is still a problem, so let's say 2.5. all right, so I think 2.5 cuts it for us. So let's increase the flex for this and then push this downward a little bit more, then probably increase this to 40. Okay, and then let's see if we can increase these icons. So 30. Okay, so if the length is greater than 1, increase the width. If a dot length is greater than 1, make it 50, else make it 30. All right, so 50 is much, let's say 40. All right, so I think 40 works. So basically enter and delete have their length greater than 1, so it will just increase it for both of them. Increase the width. So let's see if we could add a little bit more. All right, so this looks good. This looks good. All right. All right, so this is like the blank UI. So I would say we start working on the logic. Alright guys, so I took a second look and I saw that for this to work we'll need to like make a little bit of changes. Okay, see here that we are using grid view. We need to convert that to a list builder instead of grid view. So we'll do this list view builder, and then we'll need to take this out, and then instead of 30 we'll make it 6 here, and then here would use row here, and then would generate the children. So we'll use list of widgets, and then we'll generate 5, and then when we generate it we return our container. All right, so with this we need to rename this index, so let's call it column index, and then this E, let's call it row index. Okay, so instead of an arrow, let's make the return, let's make it an explicit return. Is that the return keyword, so we can use here for our logic. Yeah, I think so far this works. So let's add height. Let's say we want to use height of 30, and then let's add padding. Edging sense does all, and then we'll make it 20. Oh, 20 is much, let's say 5. All right, let's say 9, and then what do we do? So let's make it an expanded, then increase the height, let's say 45. Okay, there's still too much space, so let's say 50. All right, So for the most part, this looks good. Okay. All right, so to start collecting values from our inputs, we have to use gesture detector. We can either use gesture detector or inkwell, but depending on the use case, I usually would prefer gesture detector because it doesn't have like the feedback, like the splash effects when you click on it here. So what I need to do is I need to check if e.length is greater than 1. So that means if it is greater than 1, which means it is either enter or delete. All right, so if it is greater than 1, then I will now want to check if e is equals to, okay, let me skip this for now, then else if it is not greater than 1, then what I need to do is I need to have like, let me print what I'm getting first. So let me click on it and see what happens. All right, so it prints A for us. Let's click on V. It prints V. Let's click on H. It prints H. Okay, so I can confirm that this works. Okay, so let's create a variable to hold our inputs. So we'll call this string imputed string. It will be an empty string initially. So what we want to do here is, let's say if imputed string dot length is less than 5, so we only want to add to it if it is less than 5. So we'll have to do imputed string is equals to imputed string and then add the new value. Then after all of this, we need to set states. All right, we need to set states. Okay, and then what do we do here? We would say if e is equals to enter imputed string dot length is equals to 5. So we only want to check for our imputed value if the length of the imputed string is up to 5, and we do else if e is equals to delete and imputed string dot is not empty. So here's what we will do. Would say imputed string is equals to imputed string dot substring start at 0 imputed string dot length minus 1. So basically what substring does is it cuts off the string based on a specified constraint. So for us, we are saying from the first index up until the last item minus 1. So what this does is the last item minus 1, meaning just delete the last item for us. Okay, so that does it. And then so if you click on enter, so okay, so we need to have like an array that would hold the users, all of the users inputs. So it will be an array of strings. So what we want to do here would be so holding list dot add the users imputed strings. So this is of course after we've confirmed that the length is 5. So there's something we need to do here. We need to check that word is valid. So we need to like validate that the imputed words, I bet it's 5 letters, but it has to be valid. And then we'll do imputed string is equals to this. All right, Okay, so let's start displaying it. All right, so what do we have here? So first things first, we need to, all right, so we have this imputed string. So this imputed string would contain maximum of 1 2 3 4 5 6 words, and those 6 words will be 5 letters each, and then those 6 words is the number of tries we want the users to have. You grab. So what we'll do here is this. We'll say if column. Okay, so we even need to find a way to know what row the user is typing. So we'll do that by having a integer called typing row. No, let's say typing index. So difference will be 0. Yeah. So if the column index is equals to typing index, which means it is that particular index that we are on that the user is typing on. So prior to that, let's declare string text here and make it an empty string. So if the user row is currently under current row, so let's come here, let's add this typing row. So when the user clicks on enter and then the word is a valid word, we want to add 1 to the typing index here. So if the typing index is equals to the column row, so we want to like get the string from the imputed string. I hope that makes sense. Okay, so what we need to do here is we need to be sure that imputed string dot, or let's do that after the check. So inside here we'll do if imputed strings dot length is less than row index. Yeah, less than row index, and then if imputed string dot is not empty, so we'll do text is equals to imputed string at index of row, and then we'll use text here instead of using t. Alright, so let's test out what we've done. Alright, so it's string and error. Alright, so it's supposed to be greater than s h. So let's click on enter. This. Alright, so we have an issue where the previous imputed data clears. Yeah, so let's resolve that. So how do you go about that? So we'd need to say else if column index is less than typing index. Alright, so here the text should be, so we need to get the holding string at index of column. Let's print this and see what we have. Alright, so we have ASF. Alright, so we need to convert this to an array. So let's call this row text list. Let's convert this to an array, and then we'll do splits to list. Alright, so here what we'll do is we'll need to do text is equals to row text list at index of row index. Alright, so let me explain. So we have like the holding text here that holds arrays of words. Yeah, so we are very certain that at every point in time each of those words will have 5 characters, since we can only add to this holding text when the length of the inputted string is 5. So we are certain that it is 5 characters. So all we needed to do was to split it by creating an array out of each character by doing this, and then assigning the text variable to the row text list at the index of row index. So note that this row index is the index of these individual rows, and then the column index is the index of these individual columns. I hope that makes sense. Alright, so let's keep on typing. I'm sure it doesn't add to it. Then let's click on enter. Alright, so our input is done. Our input is done. Alright, so let's play around that. So let's try deleting stops. Okay, so the delete works. The delete works. Alright, so let's see if we can increase the font size a little bit more. Alright, so it's visible. Alright, so let's work on getting the list of words. Okay, so for that we need to like run it on the init state. So we fetch the words and then assign it a word for the moment to it. So we need to do root bundle dot get string. Alright, so we copy the path from here, copy path reference, and then paste it here. Since it's on await, we need to run our, then await it, and then do json dot decode our a. So instead of this, let's create a function that does that for us. Fetch words, make it private. Alright, let's make it final words is equals to await. So this should be an asynchronous function, and then when this is being returned, we'll say json.decode words okay, so we say button words is equals to this. Alright, so let's print to get what data type this is, so we'll know how to move from there. Alright, so print button words dot run time type. So let's rebuild. Alright, so it's list dynamic, so we need list of type string. So this should be all valid words. There should be an empty array on the onset here, and then we'll do as list dynamic, or you could just say list. I could just say list, and then I would want to map that, return each list as string, and then say list dot from. So this should be list of string from all valid words is equals to. Then let's see, I think this should throw an exception when we try to test it. Alright, so it didn't throw an exception, so I think we are good to go. So let's see if we have all the words here. Alright, so we have all the words. So let's see how many words we have. Right, so we do have 3,563. All right, so here what we need to do is to check if it is valid. Equals to 5, and all valid word contains imputed string. So basically we are saying that the words that the user imputed is a valid word before we can let them press enter. So let's say for instance we do a wiki. So we know a wiki is not a valid word, so let's try a wiki. All right, so you see it worked. So we need to like show, we need to show it those when the word is not valid. So we can do that here. We can take this out. We can say if contains this, then do all of this, else use scaffold messenger of context dot snackbar. The content should be of type string, not a valid word. So let's try that. Let's try and put in a word that's not valid. Awaki, not a valid word. Alright, so that works. That looks good. Alright, so what we need to do is to get a random word every time you run the app. So get a random word that will be matching against, and then use that to validate the imputed words. So I think let's get a random word first. So we'll call this string, and then what should we call this? Let's call this winning word. Then after we've run this, and then we need to do get the random word. Random. The next int all value words dot length. So this should be, our winning words should be equals to this. All right, so we are getting a random word for our winning word. So let's print out what our winning word is. We are trying to cheat, but let's see. All right, so our winning word is, I think it tried an exception. Why? So our winning word is bills. All right, so our random logic works. All right, so we need to match it against what we've imputed. So we need to have an enum imputed imputes validation, and then we would have right, wrong, right. So it's asking us to use small letter, right, wrong, positional. Okay, so we'll come here and then, so the color, I think we can do without the enum. Yeah, we can actually do without the enum. So let's take out the enum for now. Let's comment it. So let's say our initial color would be color is equals to colors the transparent. Okay, so here would be color. All right, so the logic only applies to the imputed, the already imputed strings. Yeah, so we'll come here. So we need to find a way to match each of these character by each of the user's inputs. Yeah, so we'll say winning the for each the splits the for each. So I need to do if E is equals to text, then our color should be our colors dot correct. So let's experiment with bills. Alright, so that works. Else if a dot contains, alright, no, we need to see if text, if winning word dot contains e, right? No, text, then the color should be our colors dot long position. Alright, bills. I think we are missing something, so let's see what the winning word is again. Bills. Okay. If this is this row text winning word. Alright, so how do we resolve this? So this is supposed to be all green. Alright, so let's try again. Let's see what our winning word is. Our winning word is, okay, we don't have a word yet. Let's say awake. Okay, so our winning word is growth. Group. All right, so I think this should come before this. Yeah, I think this should come before this. All right, so this is still not. All right, so I think that I have an idea of how we can go about it. Okay. Alright, so first thing first, we need to check if the holding list, which is a list of imputed text, is not empty firstly, and then we need to have like a color. Okay, yeah, the color property of field is here already, so we need to do the holding text dot for each, yeah, and then for each we remove each imputed. So what do we call this? Let's call this imputed words IW. Yeah. All right, so inside this IW we could have final row h imputed text is equals to IW, and then we could split it further, can do split.this and then convert it to a list here, and then since we now have it as a list, now we need to match against E. So E is this individual character, so we need to match it against each of these. So what we'll do is we'll say if, okay, so let's use a for loop for that. Int index of matching character is equals to 0, and then we'll do imc is less than h that length, and then we'll say imc plus plus. Okay, so now we'll do if winning word at imc is equals to, I think is equals to E, yeah, is equals to E, then the color should be equals to app colors dot green. That's correct, yeah. And then we need to do an else if winning word that contains E. So we know that it contains it, but it's in the wrong position, so we will use our wrong position color, and then we need to finally check if each text contains E. So we need to use transparent colors.transparent. So basically the idea behind this is if the index is correct, then the keyboard, the text, the key should be green, and then if it is wrongly positioned, then it should be yellow, and then if it was imputed and then it wasn't part of the winning text, and it should just be transparent. All right, so let's test that out and see how that would work. Okay, so our winning word is Kade, so let's use our wake. All right, so we are certain that K is not part of the word, we are certain that W is not part of the word, but we know that R, D, C, and E are part of the word. So let's try something else. Let's try there. Okay, so let's input the correct word since we already have it. All right, so this is correct. Okay, so the game logic works. All right, so what do we need to do now? So we need to check when the user has gotten the correct answer, so we reset the game for the user. So we show like a model and then reset the game. So how do we do that? All right, so in our impute method, when the user clicks on enter, all right, so before all of this we need to first check if this is this. So we check if holding string, if imputed string is equals to winning word, then do this, else do this. All right, so if imputed string is equals to winning word, then we need to show a bottom sheet telling the user that they've won. Or let's test this out first. Let's print out what we're getting first. Let's print out true to see how that would pan out. So So let's print our winning word so we know what to match against. Winning word. Alright, so our winning word is water. Okay. So let's say goofy. Okay, there seems to be an issue. There seems to be an issue. So I think there's an issue with our keyboard implementation. So let's see what the issue is. So here we are saying okay. Okay, holding text, and then there should be string and holding text. Okay, and there should be each of the string and holding text. Okay, and then we are splitting here. Holding text is 90. Okay. H imputed. Okay, so I think I need to run this check even before I run my eval statement if this contains this. So we don't run this for every single string. So if this is contained, yeah, I think this works. Right, so let's say wolf. All right, so yeah, this works. So finally, let's say water. So we're expected to see true on the console when we hit enter. Right, so we hit enter and we didn't see true. Oh yeah, so that's because we made a little bit of change here. All right, so I think this has to come here. This has to come here. This has to be here. So we need to display that these are correct before we know what we want to do. Okay, so let's try it again. Hopefully it works this time. Grand. Right. Okay. So this is still problematic. This is still problematic because this is supposed to be green. This is supposed to be green. So let's see. Okay, so if this at this index, so let's see what we have. Winning string at what index? This. Winning string at index for each letter that contains E. So if it contains E, then it should be this. Oh, interesting. So I need to match it against the index of each imputed text. Okay. Each imputed text. Alright, so let's see what we are getting. Let me click here. Then this should print everything for us. So I would say is versus this right, so we have G versus G, which is actually supposed to make the color green. Okay, G versus G. Okay. Okay, so let's see how many green. Okay, so we have several green sets. So how come it is not picking it? How come it is not picking it? So let's see if this matches. True. Okay. Oh, interesting. Okay, so let's try something else. Let's try to run it from the bottom part. Let's see if that would solve it, but I doubt that would. But let's see. Alright, so that did not solve it. That did not solve it. Alright, so after a few minutes of debugging, I was able to see what the problem is. I guess it was an oversight from my end. Okay. So due to the loop, it was sort of like overriding it and then setting this guy the color back. So let's take this back. Let's bring it back up here and then do our else if. So if this is equals to E and m.c is equals to E. Okay, so that should solve it for us. And then we need to check and color is not equal. Our color is the correct color. Okay. So this still didn't cut it for us. Alright, so I guess we have to rewrite it. So let's take this out and rewrite it. Okay, so we'll start from here. So what we'll do is holding text dot for each. So this, let's call this, what should we call this? Holding, let's call this words, and then we do this. All right, so now what I think we should convert this here. So now let's split this word. So we'll do final splitted words should be words dot splits. Okay, splitted words. So next we need to do is we need to check if splitted words that contains E. Okay, so if it doesn't contain them, we don't want to even have any business with it to begin with. And then we'll now do our position. Also now do for integer. So let's use pos. I guess we've not used pos to this, and then we'll do if pos position is greater than, is less than splitted was the length, then was that length, and then we do relation plus. Okay, and then we now have to run our checks to see if winning was as position is equals to E. And so mind you, E is the each of these letters in this case, and then our splitted words at position is equally equals to E. Okay, so we'll do color is equals to app color the correct color. All right, so that worked. So now let's break it. Let's break out of that loop. So I guess the reason why that one didn't work was because the loop was running continually, and that's not what we want. So we'll now say else if color is not equals to. So now we now want to see if the color is equals to correct and it is contained in winning words, contains E. So we'll do color is equals to app color the wrong position. Let's see. Right, so that works. So another case, so we need to break. Then another case is else return color is equals to colors the transparent, and then break. All right. Oh, okay, I think we are back at the same issue. We are back at the same issue. Okay, so this doesn't have issues. Let's see. Okay. If contains little words or contains E. Okay. A. This is correct. This is correct. Okay. Okay, so I think I need to like replicate what I did here. See if there's a way I can abstract it. So we use the same color palette for both of them. So let's see if we can do that. If we can do that, that would be nice. So here we'll say get color. Here should be color. And then we'll say string. I'll put this color here, so string imputed return color. Okay, return color. imputed. Everywhere we have imputed, take out the string, place it with imputed. So I don't really think we need most of this. We just need this guy here. We just need this guy. So let's take this back. Let's take this back. Change this to imputed string, imputed string, imputed string, and then cut this guy. So this is the only guy we need, since this is where our color changes. Alright. Imputed string, correct string. So we change our winning to correct string, correct string. Alright, so let's extract this. Let's bring it here. Get color. And then we need row index, okay, and then we need current text. Alright, so the current text should be this, current text. Alright, so let's get color. Imputed string, winning string, and then make this text. Let's see if anything will change. Okay, I think everything changed. Product contains. So let's see. Winning word text. Okay. Index is equal to current text. Current text, okay. So let's see what winning word is. Let's see what our winning word is. Our winning word is great. Okay. So let's see what our role index is. Our role index, okay, 0 to 5. And then let's see grade. Current text. Let's see what our current text is. Okay. Okay. So what text is from here? Okay, our text is empty. Alright. On current text. String. It's not empty. Alright. So I think we should rebuild. Okay. Oh, interesting. So we only need to get the color from the imputed text, or rather from our holding. So let's come back here. Current text should be our holding text at column index. So this is where it should be. It should be the holding text at column. Alright. Alright, so we should do row. Okay. If holding text that is empty, then send a null, else do this. Alright, so allow this to be nullable. Okay. If return text is equals to null, then we should return color just the way it is. Okay. Renown, not a valid word. Regen. Let's use angry. Alright, so where's the error coming from? And I guess we should just revert this and then find another way to resolve this issue, because this seems to be messing up with what we've done so far. Alright, so let's sort of like revert this, then it brings us back here. Okay, adore. Great. Okay. Woman. Okay. Oh, alright, I think I get what's happening. So this guy runs over the loop and then it gets the, so it sort of like gets the string and then runs over it again. So for instance, we say women here, we said E here, so it already, say for instance in mark, it ran this first one adore, so it already sets the strings of adore as O as being in the wrong position. Then when you now run great again, it no longer resets this to green, so it doesn't pick like the recent index. Okay, so I think we need to find the way around it, and I'm very sure we will find the way around it. Alright, so I think one way we could go about it is to have different sets. So say we have, so this is experimental, so let's see how it will go. Correct, then this will be a set of correct. Okay, say okay, so I say correct and wrong. Alright, so what we'll do here is this. Let's say for each of these we want to add to our correct, add it to our correct. Okay, this, meaning it is not correct, then add it to our wrong. Dot add E. Okay. Then we can take this away. Take this away. Or we can leave this here. We can leave this and then add this. And then here, what we can do is, instead of explicitly specifying the color here, what we can say is if correct that contains E, then use app colors that's correct. Else if wrong that contains E, and use colors that transparent. Else use color. Okay. Okay, so let's see what we have in our corrects. So we have W. Okay, so we should have O and M. So let's see. Alright, so I kind of noticed that there's an issue with our for loop. Yeah, so there's an issue with our for loop. So let's see if we can do it another way round. So let's say winning dot splits the for each winning, and then we'll do splitted strings for each. So then the each splits, and then here we'll do if each winning is equals to each if each split is equals to each winning, then we have our color as this. Okay, so let's see what happens. Let's test this out. Alright, split each winning is equals to this. This is each winning, each splits. Let's set this. Okay, so this is equals to E, and this is equals to E. Equals to E. All right. So W, yeah, O, yeah, M, yeah, N, yeah. So E is not supposed to be a part of it. I wonder where the E is coming from. Women. Okay. if h is equals to e and h splits is equals to h winning. Print h winning h splits. Okay. Okay, so take this upward. Okay. All right. Alright, so let's see if we can resolve this by using another method. So this didn't work. I can tell this is already causing an issue, so let's rewrite it from scratch. Okay, so if this is not null, if this is not empty, then we'll enter as for each, and then this should be each word. And then we need to assign the color. So we need to say if each word dot contains e. So let's assign a color to it. So let's say our colors dot wrong position. All right. So this is all the inputs we have at the moment. All right. So another check we need to do is if winning word dots doesn't contain e. So if it doesn't contain e, so we should assign color to our color. Instead of our colors, we should use colors dot transparent. Alright, colors are transparent else equals to winning word. Colors are transparent else. Here we can do a for loop. For I is equal var, instead of var, let me use int I is equals to 0. I is less than each word dot length, and we could say I plus plus, and then it would do if each word at index of I is equals to e, and winning word at index of I is equals to e. Yeah, so we can break the loop at this point, after which we'll assign color to our colors that's correct. Alright. Alright, so I think this works. So first off, field color, so this is assigned to field color. Okay, so I think we need to put this guy right inside here. Alright, so I think this works, so let's test it out. So let's get another word. Another word is mayan, so let's say mayo. Okay, so let's say let's say if main is a real word here, or not a word, so let's say maize. Okay, so let's say local. Alright, so let's keep trying it. Let's say amaze. Alright, so let's say mayan. Alright, so that's correct. Okay, so let's handle our correct states. So let's see. This is supposed to print true. Alright, so true was printed. Alright, so we need to show the user something to tell them that okay, they found the word for today. So I think we also need to add this string and then alright, okay, so I think we can use this scaffold, or let's use a model container that is inside the column is controlled, would make that true. Then background color, blue colors, the transparent. Let's see what happens. Alright, so this is it. Alright, so let's specify child. So let's use a proper, and then style, let's make it a text style of fonts. Use font size of 50. And let's hit it again. Alright, so it went all the way. So let's centralize it, and as this is the center, then let's decorate it. So we use a corrected box to give it a background color of colors that's white, border radius as circular. So let's say reduce 10, and then for the message we could, let's wrap this inside the column and then say congrats, you guessed right. And then let's have another text saying start a new game. Let's use 15. Alright. Okay, so let's make this 15. Let's make this 15 with the font width of 700, and then with a color of our correct green, and then let's add a little bit of spacing here, and then let's increase the font size for this. Alright, so let's see what that looks like. Okay, so we can take this out, we can make this 10, then we can add padding here, so this looks good. Horizontal 30. So let's see what it looks like. Alright, so this looks good. So let's increase the font size for this. Let's add padding to this container. Alright, edge inside starts all. Let's add 10 pixels padding. Alright, so let's centralize the text. I feel like this text is too big, so let's see what 25 looks like. Then let's add the font width, say 500, and then text alignment. I'm in the center. Okay. Alright, so let's add a little bit of spacing at the bottom. Alright, I believe this looks good. So when the user clicks on start a new game, we want to close this window. So we want to close the modal. In the same vein, after that, we want to reset the game. So we'll do then. So to reset the game, we need to have a method that resets every value we are working with. So we'll call this resets. So what are the things we need to reset? So first off, we need to get our winning value afresh, and then our typing index has to be 0 all over again, and then our holding text has to be empty, and then our imputed string has to be empty as well. Alright, so once the user closes the modal, we want to call reset. So this automatically resets the game for us. So let's try that. Okay, so there was one part missing, so there's supposed to be a set state here. Right, so our winning word is virus, so let's say hello and see if we guess that right. No, it's not part of the word at all. So let's say virus. So let's see amaze. All right, what was here? So let's say Venus. All right, so we now know that there's V, there's U, there's S. Okay, so we could say, let's get it now. All right, congrats, you guessed right, start a new game. All right, so one last thing, let's add margin to this container. So let's add margin So this is our toast when the game is done. So let's add margin to it so it looks better. The symmetric horizontal, so let's say 20. Okay, all right, so we can take out this print statement. Now we are sure of everything. We are sure everything works. All right, so we can delete this, just a little bit of cleanup. All right, so let's say drawn. All right, so we know there's a D, there's an E, but they're both in the wrong position. Okay, great. All right, so we now know our word has E at the middle index. Okay, hello. All right, so our game works as expected. All right, so let me sort of like walk us through what I did. So let's commit. So we'll say works. All right, so basically we have like the home screen, and then we have our keyboard keys. So our keyboard keys contains array of 3 different arrays representing each of these arrays for the keys, and then we have an imputed string which holds each of the user's inputs and can only accept max of 5 possible inputs, and then holding text which holds each of these already completed rows, yeah, and then the typing index which sort of like tells us which index the user is inputting for. And then we also have the winning word. So the winning word is the index that the user is trying to guess. And then we have this fetch word. So this fetch word is being called whenever the user opens the app. So it's being called on an init state. So what fetch word does is it loads up this 5-letter words JSON. So this is the 5-letter words JSON. This is what it looks like. It's a JSON containing 5-letter words, right? So JSON containing 5-letter words, and then after that, you assign a random word to the winning word, so just like a random word. And then we have a reset. So we call this whenever the user finishes the game. Okay, I think there's one more thing to do here, but I'll get back to that. So this resets the game when the user wins, and then updates it typing index to 0, clears the holding text, the imputed string is made empty, and then the state is being set. Okay, and then for our logic here, so we said the default color should be transparent, and then if the column is equal to the typing index, so if the column is equal to the typing index here, so we need to get the text that was imputed already, and this we only getting the text after the user has filled for each of these rows. Yeah, so when they fill out for this row, that's only when we can like check what the value is compared to our winning text, and then know what color to use. So that also explains what we have here. So if column.typing index is less than this, or rather this is it. So if column index is equal to typing index, which means you are currently typing, yeah, so the text would be equals to the row index. Yeah, and then if column index is less than typing index, obviously then that means we've passed that, then the text will be equals to row, the holding text at the column index. Yeah, and then that also determines what we use for the color. Yeah, and similar thing applies to the keyboard. Okay, and then here we said if the key the user inputted is enter, then we want to perform this logic. So we have series of logic here. So we check if the imputed string is equal to the winning string, and then we show this user this model, and then reset the game for them. If it is not the winning string, then we set typing to index +1, and then set the imputed string to empty, which means it can start typing. And then we also sort of like validate to see that the word is an actual word. If it is an actual word, then the logic continues, but if it is not an actual word, then it throws this exception saying not a valid word. And then if it is deleted, we just take out the last item from the imputed string, and then for every other thing we sort of like just append the letter to the imputed string. So that's how it works. So there's this logic I missed. The logic if the user didn't get it correctly and they've exhausted their tries, so what happens then? All right, so let's look at it. So say, okay, if this is this, else if so we need to check the length of the holding text. If holding text dot length is greater than 1 2 3 4 5 6, so if it is greater than 5, which means it has maxed. So what do? We need to show them a toast telling them you exhausted your try. Have exhausted your try. All right. All right, so we'll change this to this. Oh, sorry. Alright, so I'll change this to this. Inform the user that they've exhausted their tries. So let's see. So let's say hello. Kings. So we'll intentionally fail. So we'll do cried. You have exhausted your try, start new game. Or to make it more engaging, so we could say your winning word was winning word. Invalid constant, so we need to take this out. All right, and so we can do this. All right, so let's try. So let's just keep saying hello. Health. Hello. Amaze. What do we use now? All right, so let's see. Alright, so let's just use any random word. So let's use hello. So let's say hello again. Hello. Alright. Repel. So it says our winning word was repel, so we can make this 20. I'll say 15. We can make this 15 and then make it 800, so it is well pronounced. Okay, so let's try. Not the word. below. All right. Your winning word was flock. All right. So I think this makes sense. This makes sense now. All right. So if you're with me up until this point, drop your likes, drop your comments, drop your suggestion, or whatever questions you have, and I'll do well to upload the code to GitHub, and I'll drop the link on the description. Thank you guys for coding along with me. See ya.